All right, so we're going to start off by reviewing our quiz from Friday. Question number 1 says, in a certain quadrilateral, one pair of opposite sides are parallel, and the other two opposite sides are not congruent. Clearly, that means none of these sides are congruent, and this figure could only be a trapezoid. So if we look at these two sides as being parallel but not congruent, and the other two sides here and here being not congruent, then this is going to always be a trapezoid. Be careful to read this question carefully, reviewing properties. Question number 2. This asks you to find MN in the trapezoid. Clearly, MN is going to be the mid-segment, and we know when we have the mid-segment, we're looking for the two bases added together divided by 2. Clearly, we've added them here, 12 and 28. Divided by 2, we're going to get 20. Okay, so this question says in rectangle ABCD, draw the rectangle. That's always what you should do first. AC is 4x plus 5. And then it says BD is 5x minus 15. This problem is unsolvable unless you understand that in a rectangle, diagonals are congruent. Clearly, if we know diagonals are congruent, we can set these two diagonals equal to each other, and we'll get x equals 20. But that's not what the question asks, and a lot of you missed this on the quiz because you didn't read the directions and carefully. You need to do that on the Regents for sure. Let's find AC. So clearly we see AC here is 85, and that is your answer. Last question says find the value of x. Angles always total 306 degrees of any polygon. That's why I clearly circled it here. So now we just need to add these all together and solve for x, setting them equal to 360. If you divide both sides by 5 here, after we've simplified it more, we're going to get x equals 56. Be sure to make corrections and come in on Tuesday after school to try and get your points retrieved. All right, so the new lesson today is 5-7, polygons and quads. And again, your objective today is going to be, I can classify polygons in the coordinate plane. We're actually going to use coordinate geometry. Coordinate geometry is really cool because we actually are going to focus on using coordinates, like 3, -6. So coordinates, and we're using coordinate geometry. Okay? Very important idea today. Our working today, you should be thinking about 3 things. I can actually figure out the perimeter of a figure. I can figure out the area of a figure, and I can also classify the figure. I can tell you whether or not it is a scalene triangle or a rhombus, and I can tell you what the area, perimeter, and again the classification is. So classify. All right, so let's go, flippers. So the first definition today is going to be just what the coordinate plane is. I know we say coordinate plane a lot, but we don't really know that students understand that. But the coordinate plane is going to be the plane that contains the x and y axis. And many of you know this and can actually explain it, but we want to make sure that we understand it. The next thing I have here is a kind of a chart for you, and it has 3 really big ideas. The distance formula, which you will need to use today, or Pythagorean theorem. Okay, remember the distance formula itself is literally just a manipulation of the Pythagorean theorem. So let's actually just write that down over here, just so that if you want to use Pythagorean theorem, a squared plus b squared equals c squared, that's also fine. They're both equivalent. Remember, you're going to use this to help you figure out if sides are congruent and if diagonals are congruent as well. Okay, the midpoint formula is something we've used before and we're pretty successful at. We add the x's or we add the y's and we divide by 2. And we get 2 actual numbers that give us a point on the graph. Okay, and we use this to determine the coordinates of the midpoint. And again, if diagonals are bisecting. Okay, so now the slope. We also want to know the slope of lines. If we know the slope of lines, we will know if they are perpendicular or not. And that's something very, very important to figuring out, hey, if I have a rectangle or if I have maybe a rhombus, if I'm looking to see if the diagonals are perpendicular when they bisect each other. So let's try our first problem here. So our first problem is going to be looking at this figure, which we're saying is a parallelogram. Remember, we're finding 3 things: area, perimeter, and classifying it. Okay, so to figure out the area here, we want to just basically change this parallelogram into a rectangle to see what that simple area would be. And we do that by drawing triangles to make this into a rectangle. So let's do this together. So here I'm drawing a blue line down from that vertex over into the next vertex. So now that kind of looks like it would be a triangle fitting to a rectangle. I'm going to go down from R here. I'm going to go down and then all the way across to T. Then I'm going to start from T and go up to P. And then I'm going to go up P over to A. And what you can see now is we've kind of boxed it off. So now if I were to draw in the other two little boxes on the end here, then this basically is now a rectangle. And if we count up and then across, so let's see, this is a 6 by 8 rectangle, which would be 48 units. That would be the area if this was just the rectangle. So now we need to figure out, well, what are the pieces of here, this 2 by 2, this 2 by 2, and then all these all of these triangles that we've made. So this triangle here, this triangle here, here, and here. And once we subtract those from this amount 48, we will have the area of the inside figure, which is kind of cool. Let's start with this triangle here that I've highlighted in black. And for this vertical length, or this horizontal length here, this is going to be 6. Okay, and we know that over here this is going to be 2. So this is a 6 by 2, which means that this triangle inside would actually be 6 times 2 divided by 2, which is going to give us literally 6. So this area of this triangle is 6. The area of the box next to it is a 2 by 2 box, so this is actually 4. And we want to keep doing that for the rest of the remaining triangles and squares. So over here, this one right here is going to be a 2 by 4, which would be 8, but we have to divide it by 2, so that's 4. And then if you look over here at this triangle, what's kind of cool is that this one is a carbon copy. It's a similar congruent triangle to this one. So the area is going to be identical. So this area is going to be 4 here. The area of the one down below is actually the exact same as the one above. And that one's going to be 6 also. And then we've got 4. So now to find the area of the complete figure, we're going to say, well, we had with 48. We started with 48. And then we're just going to subtract everything that we found. So we've got 4. We've got another 4. And that's taking care of this 4 and this 4. And then we've got 2 additional 4s, which is going to be 4 minus another 4. So that could have been just 4 times 4. And then we've got 2 6s that we want to subtract as well, a 6 and a 6. So minus 6 minus 6. And our answer should be 20 units. Now the perimeter should be really quick because now we need to figure out, well, what are the actual lengths of those sides? Now we're going to use Pythagorean theorem. So let's start with this side over here, PA. So we're trying to find PA, which means we need to figure out what are the other sides. So let's draw a triangle here. So P, and then over to A. We know this side here is 2. And we know from just doing this a minute ago that this is going to be 6. So now we're just going to use Pythagorean theorem, which basically says that 2 squared plus 6 squared is going to equal that other side squared, which is PA, which is what we want. So this is going to give us 4 plus 36. And if we take the square root, we're going to get C equals the square root of 40, which is the length of PA. That's the measure of that side. So that's how long this side is. So trying to find perimeter, we found one side. And we want to do that for all 4 sides. Now, if you go through the problem, you'll see that PA turns out to be the same side as TR because both of these have a length of 6 and 2. So when you use Pythagorean theorem, you find that these are both radical 40 and radical 40. The same thing is going to be true for AR and PT. 4 by 2, we're going to find that the length of this side, AR, turns out that that's going to be radical 20. Now, I talked the last time we had class video about radical 20 and radical 40 being able to be simplified. But for today, I just want to go ahead and say we can just add these two numbers together to get. So our perimeter would be clearly 2 radical 40 plus 2 radical 20. Now to classifying, well, that should be really easy. We can clearly see from the picture that two sides are congruent and the other two sides are also congruent. We also want to say that this is going to be a parallelogram. We are not able to say this is a rectangle because clearly we don't have any right angles. We could definitely prove that by finding the slope, but that is very evident in the picture. So we're going to say this is simply a parallelogram. All right, so let's look at some more examples. This one says find the area and perimeter of this figure. So let's draw in our triangles to make our rectangle. As you can see, I've drawn in 3 triangles, and now I want to put in the actual side lengths of them to show the measurements. And the lengths here are 3, and this other length is going to be 4. So now I have 2 measurements. I can figure out the side AB by going 3 squared plus 4 squared will equal C squared. Then I will get 9 plus 16. Many of you know the answer to this question already. If I take the square root of both sides, I'm going to get C equals 5. So that means that this length AB is 5. So let's do the rest. So here we found all the sides now. This triangle here, 3, 4. BC turns out to be 5. And at the bottom we've got 1 and 7, which makes AC. This makes AC clearly radical 50. So now I'm able to say that the area of this figure is going to be calculated by finding the area of the rectangle, the big rectangle here. And that's the rectangle I'm talking about first. Find that. And that's actually going to be 3 plus 1, which is 4, by 7. So 4 times 7 is 28. So that's the big area of the big rectangle. Now we've got to subtract these smaller triangles that we kind of made, and we'll figure out what's left over inside. So here we've got a 3 by 4 triangle, which is 12 divided by 2. So the area of that one will be 6. So we're going to subtract 6. Over here we've got a 3 by 4 again, a little different though. And we're going to divide that by 2. We're going to get 6. And then down here we've got a 1 by 7. We want to divide that by 2. And we should get 3.5. Which would make our area of the figure 12.5. Now we just need the perimeter. Perimeter is really simple for this. All we have to do is add up those lengths of the sides of the actual figure itself, which would have been 5, 5, and radical 50. And that literally is our solution for perimeter. It's going to be 5 plus radical 50, which turns out to be 10 plus radical 50. And again, we will simplify this radical later. So we've got our area, we've got our perimeter. Now we just need to specify the type of polygon this is. And that simply is going to be, well, we've got 2 sides that are congruent in a triangle. We know this has to be an isosceles triangle. So let's look at our example number 3. We want to find the area and perimeter again. So this one's easier, obviously, because it's a rectangle. See, our rectangles are so fun. So we just want to figure out, again, the length and the width. And we don't have to build any triangles around this one because this one has lots of right angles. So we're easily able to find out these vertical and horizontal lengths. So let's do that. This is clearly a 10 by 6. So the area of the bigger rectangle, which actually turns out to be the area of the figure we want, is going to be 60 units. And all of these units, when I talk about areas, should be squared units. If I haven't been saying that, I should be ashamed because they are areas, so they're squared units. Okay, so now let's actually figure out what the perimeter is. And again, it's going to be a simple thing to do because the perimeter of this figure is going to be simply 2 times the length and 2 times the width. So that's 2 times 10 plus 2 times 6, which you should easily get to be 20 plus 12, which is going to be 32, just units because it's perimeter. Okay, and now we need to specify the type of quadrilateral that this is. Now, it would be really easy just to say, you know what, this is a rectangle. Just by looking at it, I can see it has right angles. But for this question, we're going to go one step further, and we're going to determine that these are either right angles or that these diagonals are congruent. Okay? I'm going to draw in here the diagonal from S to T. or S to U, excuse me. And then we're going to figure out what the diagonal is again from T to V. If they're congruent, this has to be a rectangle. Clearly, Pythagorean theorem says that this 6 squared plus 10 squared is going to give us our C squared. And if we look at our figure, here's where I got my 6 from, here's where I got my 10 from, so that would give me my CSTV, but that also is going to be true for my TU and my TS, which would give me my SU, my other diagonal. So if we do either one, we're going to get 6 and 10, which means we're always going to get a radical 136, so that means these two are going to be congruent diagonals, thus this is a rectangle. I realized that the video today was massively long. This is the secret hot question for today. Lots of practicing with coordinates today, but really, really good. It says, find the area in the perimeter of this figure. Specify which type of quadrilateral this figure is. Good luck.